So in this class, we will discuss a problem on gravitational motion. So now in the earlier lecture, I had discussed about linear motion. Now gravitational motion, the equations, fundamental equations of gravitational motion. That means when a body is projected upwards or downwards, and then the equations of motion will be like this: V is equal to u plus gt. So instead of u plus at, it becomes u plus gd, where g is the acceleration due to gravity. So the value can be taken as 9.81 meter per second square constant. Second equation is s is equal to ut plus of gt square. And the third equation is v square is equal to u square plus 2gs. So a is replaced by g. Acceleration in the case of linear motion, acceleration due to gravity in the case of gravitational motion. So these three equations you can use when the body is falling down. That means when the body is moving towards the center of the earth. So then we are going to take as plus g. When the same equation we have to take minus d if the body is projected upwards. So there are two cases here. If the body is projected downwards or it falls downwards due to gravity, please remember that the value of g you have to take positive, whereas if it is upwards it is negative. That means the equations of gravitational motion when the object is projected upwards is the d is replaced by minus d. That means v is equal to u minus gt, then s is equal to ut minus of gt square, and v square is equal to u square minus 2gs. That means it is similar to the case of retardation or deceleration in the case of linear motion. Now these equations you should remember. So there are two cases here when a body is projected upwards. So these are the sets of equations we have to use. When it is falling down, these are the equations we have to use. So because when it is projected upwards, naturally it has to come down. So both the sets of equations we have to use. Now here, how to solve this problem? Let us see. Here a ball is thrown vertically upwards. So now let us consider upward motion. There are two balls here. Now I will take one by one. All of you clearly note this upward motion of first ball. So there are two balls here in this problem. Upward motion of first ball I will take first. So that means I have to use these equations minus. So what is the data he has given? A ball is thrown vertically upwards with an initial velocity he has given 36 meters per second. So that means it is like this. It is thrown upwards. Initial velocity is u here. This is 36 meters per second. So after reaching certain height, so let that height be h. It comes to less. That means your final velocity will be 0. So now we don't know the value of h here. So what we have to do here is in this we have to calculate two things. By knowing the velocity, so you can calculate one thing, time. Time you can take the calculate t1 I will take because it is upward motion. Now another thing is I use this h value. That is height to which that ball is thrown, first ball is thrown. So these two are the unknowns in this case. Now this is the first thing. Okay. Now what I will do here is I will use these equations because this motion is upwards against the gravity. G is negative. So let me use the first equation because v and u you know. G value is 9.81. T is nothing but t1, time taken by the ball to reach that height h. So I will use this equation. U is equal to v is equal to u minus dt. That means v is 0 here. 0 here. U is 36 meters per second. Suppose if they give you kilometers per hour, better you convert to meters per second. Minus g is 9.81. Minus stands for the body is moving upwards, and t becomes t1 here. So from this term, you can get the value of t1 in seconds. So that is the time taken by the first ball to reach the maximum height. So h is nothing but here, h is the maximum height reached by first ball. Reached by first ball. So it will be in meters. And t is the time taken to reach that height. Now if you simplify this, you will be getting t1 as 36 divided by 9.81. It comes out to be 3.669 or 3.67 you can take, 3.67 seconds. Now you can calculate this h also. H is given by the second equation. S is nothing but h here. Okay, this S is nothing but h, distance traveled. So I will use that second equation. S is equal to ut minus half dt square. Here once again t is nothing but t1. U value you know it is 36 meters per second. S is nothing but h. G is 9.81 meter per second square. And t is nothing but t1 which we have worked as 3.67 seconds. Now substituting these things in this, you will get h is equal to u is 36 into t1 is 3.67 minus half into 9.81 into 3.67 square. So if you simplify this, we will get 36 into 3.67 is equal to minus 0.5 into 9.81 into 3.67 square will be equal to 66.06055. So 66.055 meters. So this is the height of the first ball. So that to reach that height, it has taken 3.67 seconds. Now, what we have to do here is, now let us find out after reaching this, it will start falling down. Now, I will take the downward movement of that first ball. So, downward movement of the first ball. So, upward motion I have taken. Second part is downward motion of first ball. Downward motion of first ball. That means the ball after reaching that height h, it starts falling down. So here what happens? The initial velocity we have to take 0. So and this distance, whatever distance it covers from here to here, I will take it as h1. So now, what we have to do here is, after what he has given here is, another ball is thrown after 2 seconds vertically in the same vertically upwards. What should be its initial velocity? Second ball initial velocity, so that it crosses first ball at a height of 30 meters. That means here please note that another ball is thrown upwards like this. This is the ground level. So ground level I will take here. Something here. So second ball is thrown upwards like this. This is second ball. This is first ball. Somewhere in between, these two balls will meet. So let us take the point is A. At point A, these two balls will meet, but we don't know with what velocity the second ball has thrown. So that's what we have to find out. And of course, the second ball is thrown after 2 seconds. After the first ball is thrown. Now, what we have to do here is, first of all, we have to see that the total height here is, the total height, we know that it is h. So h is equal to, what is that, 66.055 meters the first ball has traveled. So this distance he has given, because he has given that the second ball should meet the first ball at a height of 30 meters. That means This distance is known now. So therefore, h1 will be now this minus this 66.055 minus 30, which is 36.055 meter. That means, so the first ball has fallen a distance of 36.055 meter before it touches the second ball. Okay, or before it crosses the second ball. Now u is the unknown here. So initial velocity of the second ball we have to find out. So what we have to do is, for that case, we need to take the equation here from here to here, because I am taking first ball downward motion. So what are the data you know? So distance traveled in the downward motion of the first ball, I know that S is equal to, that is equal to h1 36.055 meter, and what else is known here is, only thing is you need to find the time. What is the time taken? So time taken, I will take it as t2. T2 is the time taken for the first ball to reach this point from here to here. So u value is known. So initial velocity you know, and s you know, distance traveled you know. So you need to calculate T2. So for the first ball in the downward motion, this is data you know. So since s is known, I can use the second equation. S is equal to, so this equation I can use, because there is not this equation. Because in the downward motion, I have to use s is equal to ut plus half dt square. S is equal to ut plus half dt square. So for this, in this equation, you know the value of s, you know the value of u as 0, and t is t2, d is 9.81. So substitute here, 36.055 should be equal to u is 0. So therefore this becomes 0. Half into 9.81 into t2 square. So from this you can get the value of t2. That means t2 is the time taken by the first ball during its downward motion to cross the second ball. So if you simplify this, 36.055 into 2 cross multiplication divided by 9.81. I have to take the square root of that, so it comes out to be 2.71 seconds. So the meaning of that is, for the first ball to travel from here to maximum height, it has taken 3.67 seconds. Then to travel from here to here, it has taken 2.71 seconds. That means the total time taken by the first ball to go to this position and then once again to come back to this A will be t1 plus t2. So total time taken by first ball to cross the second ball. To cross the second ball is t1 plus t2, that is 3.71 plus, sorry, 3.67 plus 2.71, which comes out to be 3.67 plus 2.71, 6.38 seconds. So 6.38 seconds is the time taken by the first ball to reach the maximum height, and once again to move downwards to cross the second ball. Now, now what you have to do is, he has given after 2 seconds. After 2 seconds, the second ball is thrown. That means what you can take for the second ball is this, whatever time taken by first ball minus 2. So that is the time taken by the second ball. Now I will take this as the time taken by second ball. If I take it as t3, so according to this, so the meaning of that is t3 will be equal to, so 6.38 seconds taken by first ball minus 2, because I have to deduct after 2 seconds that second ball is thrown. That means it is 4.38 seconds. 4.38 seconds is the, so this is the time taken by second ball to cross first ball. So the difference in time you have to take. Now the second ball, I will take the upward motion of second ball, because second ball is only moving upwards. There is no downward motion. Upward motion of second ball, if I take the equations, corresponding equations for upward motion is this negative. So that means it is like this. See, now I write the equation for second ball. This velocity I don't know, u value I don't know, u I have to find out, but this distance I know. Distance traveled by the second ball will be 30 meters, because it crosses the first ball at 30 meters. So this is the A, point A, whatever I have taken reference. This is the point where the first and second ball they cross each other. Now the time taken for this is how much? 4.38 seconds. So you know the distance traveled, you know the time. So you have to find out the initial velocity. So we have to use once again the second formula here, because it is thrown upwards. So this you know the distance 30. S is 30 meters. T value you know, u you can find out. So now I have to use the second equation. Upward it is the negative equation of dt square. Please note that S is 30 meters here. T is T3 here, it is 4.38 seconds. Then of course u is unknown. So this u you have to find out. D is 9.81. Now substituting here, so 30 is equal to S is 30, u is unknown, into T is 4.38, then minus half into 9.81 into 4.38. That means if you simplify this, you will get the value of u. So let me calculate u there. 30 plus. So if I bring to this side, 30 plus half is 0.5 into 9.81 into 4.38 square. So that's what we are going to get. That divided by 4.38. So that is the answer. 28.33 meter per second. That is the velocity with which the second ball is thrown, so that it thrown upward, so that it crosses the first ball at a height of 30 meters. So this is the problem regarding gravitational motion. So in the case of gravitational motion, the difference is you have to replace that acceleration due to gravity A value by the acceleration A value by the acceleration due to gravity value 9.81 meter per second square. And another thing is, if the motion is downwards towards gravity, so you have to take a plus in this set of equations. If it is thrown upwards against gravity, then G becomes negative, so minus you have to take. And initially it will be having some initial velocity, and when it reaches some height, final velocity will be 0. That is to be put in mind. So when the ball is thrown upwards, initial velocity will be 0. Initial velocity will be having, final velocity will be 0. Whereas on the other hand, when it is falling down, initial velocity will be 0. It starts from west, and final velocity will be having. So these are the things you understand. So please note that anything, that means whatever data he has given, in some of the problems they may give distance traveled, in some of the problems they may give time. So normally these two are the things, the velocity, time, distance traveled. These are the three things, parameters which are used in gravitational motion. Whereas in the case of linear motion, acceleration also will be there, because that is not constant. Whereas here, acceleration is replaced by g, and its value is taken as 9.81 meter per second square. Only three parameters will be there here: time, distance traveled, and velocity. So in that velocity, of course, you know one of the velocities will be 0. When it is thrown upwards, your final velocity will be 0. When the body is thrown downwards, your initial velocity will be 0. So like that, whatever is asked, so we have to formulate the equation yourself. So remember these sets of equations: when it is plus, when it is minus, and you can proceed.